So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 199. In this video, we continue with pointers. In our last video, we already created a declaration of a pointer and we assigned also a value. First of all, how we declare again a pointer, it's similar to a variable. We have a variable name, we have a type, and the only thing which is different, we have a special symbol. It is this asterisk. This asterisk indicates, if it's on the left side, that we are going to declare a pointer. And what we have here on the right side is an assignment, like our standard assignment operator here. And we assign a variable, but interesting is this ampersand in front, which says this is not just a normal variable assignment, this is address of assignment, which means this ampersand asking this variable, please give me your memory address, and after this one it will be assigned. So after this ampersand get this memory address, this one will be assigned to this pointer variable. And what a memory address looks like, we can see here there's some examples. And now we have a big question. What is this big question? The big question is, we as a programmer, we learned that we work with variables, but we was all time interested in the values of the variables. That's why we created variables, we assigned variables. All time we are interested in these values as a programmer. And with pointers, we have now a problem. So not a real problem, but what is a problem? Like, let's watch this declaration again, and we see this one is the value. But this value is an address, a memory address. And we as a programmer, we don't work really with memory addresses, because we are interested in values, not the memory address, at least not at a starter. So as a starter programmer, so we are starter level, we are not interested in memory addresses. This is the job of the compiler. He is working with memory addresses and so on. We are interested in values, but here again, a pointer's value, this here is a memory address. And now we have to question us as a programmer ourselves and say, what I do with this memory address. I mean, how I am using that, and why is this a memory address? Because this is what we're doing with that actually. And now we will solve some of these questions here. First of all, let me go back to my diagram here. That was what we created in our last video. It's the same thing what you can see here. This line here, I copied it and I pasted it here to this side here. And then I set the pointer when we create it, it's just creating this pointer variable. And it's asking for a memory address, and I made here an arrow, which is then pointing to this memory address, which is on the right side, this memory address of this my telephone number here, for example. And this arrow here I set, when we use a pointer, it is indeed a called pointer. Be careful, this reference here has also something like an arrow, but when it comes from a reference, we call it a reference. So, but they are similar, and that's why some people say pointers and reference are similar, but careful, they are not. They have a similar behavior, but they are not similar. That's very important. We will learn a little bit more. So, and let's go on. For example, let me repeat this fast too. When we have here a reference here, when we look this reference here, it's just a reference name. It has here this arrow. It's just like a pointer, but we call it reference. And when we look now again here, this pointer variable, it's also just a variable and has also this arrow here. It's called a pointer, but they are pointing to the same memory address here. And we will see how they behave a little bit different. Let's see this again. So I switch here. And one difference I already pointed out in the last video, for example, here, a reference need only at start on the right side a L value, which is just anything which has a fixed storage place, which can be accessed, changed, and so on. In our example, I created here a variable. When we create a variable, it creates here this fixed storage size and then assigns the variable name to it. And if you have a value, it assigns also the value for it. That's when we make a reference to it. And this counts only with references. And let's compare this one now to this pointer. Now we have here a pointer declaration, right? Let's compare what happens here and what's the big difference. So here a pointer is created, okay? And we need assigning here directly this one here, this operator, address operator of is asking, let's say so, this one is retrieving first the address of the variable which we write it, and then it assigns it to the pointer, which means this pointer variable here, which I created, will pointing directly to this address which we passed here. So that's a little bit similar. So the diagram looks similar, but here is the first difference. The difference is the start point here is just a normal variable, and here we have this ampersand. Okay, address of operator, because I want your address directly. This one, the reference here is not asking directly for a address. What I mean with that is, let's go here, because this one here, this address reference here of this address is asking just for anything which has a storage type, storage in the memory, right? My telephone number is a just normal variable here, which means here on top, and this one has a memory address. So I used here a reference, and this one you can see is more or less not absolute accurate, because this one is not really asking directly for this memory address here, but the compiler is working with the memory address, and the compiler behind the scene, when you create a variable, they connect this anyhow, so we know they belongs all together, and that's why I have made here a reference directly in. But important note here, a reference at start is not directly asking for a memory address. This is just asking for something which has a storage which has a memory address, but we are using just the my telephone number here. On the other side, our pointer here, he don't care about the variable name, because let's say other way around, he cares about the variable name, but he asks at the same time for the variable's name's address. So which means we can think about it, it goes one step further. First of all, which the pointer says, I need this address here, but you can specify from where you get it. For example, you want it from this telephone number, no problem. Then use this address of operator and give me his address. And this address of operator is exactly saying this is the address of this variable, and we are pointing now exactly to this location here. So that's much talk, but let's watch this here a little bit more in detail, what happens next. Okay, we understand this. This has not the same start points. Okay, fine. But what is the next step? And the next step is very important now. The reference here, I can use now this reference value like I showed you here as a normal variable, right? And now important point comes here. I can assign now a value it. So that's what a programmer does, right? We as a programmer, We assign values to our variables. We use them, we change them, yes, we do anything all time with the values, but we work with the variables, of course. We work with the variables, but we are interested on the values, and here we are working directly with values, right? That's the normal way. And when we watch this here on my diagram again, you can see this line here is just working directly with this lower part here, which says address and then here the value. Important is here, this reference is still using value as normal things, what we expect. And what we are expecting, this int, for example, right? This is defining, it's defined, give me something which is int, for example, in this case. Int, we had learned, is a number between minus 2 billion anything and then plus 2 billion anything. This is the range of these int numbers, which are full numbers, and we can type one of these numbers here in. All right, that we know already. And when we watch again now this pointers, and yes, that is not the case here, because after I assigned here a value, which is the address, the question is now, okay, we have here the variable, we start again there. It is a pointer to an address. We get this from the right side from the assignment. Okay, I hope we understand this so far. It's not very difficult. And now, as a programmer, we are not interested in this address here, right? We are not interested in. We want actually this value here of this address. Yes, the compiler is interested behind the scene. He is interested only in this address here because he knows how to add something to the address and remove something from the address. But we as a programmer, no, I have now this address, but I'm not interested in. And we have to find a way to get now this pointer variable needs a way to get access to this value of the address. And that's our job, and that's the problem here, because the pointer value is an address. Like I said, here something like this, an address, memory address, which we can't really use for. We can use it definitely when we go advanced and so for other things, but not for normal programming things, because like I said, we are interested now in this values, and now we have to get these values. And when we watch this diagram, how the hell get for example this reference, this value here? And that's another difference. This is another differentiation about reference and pointer. The variable here, like I showed, is just using the variable name, because this one is marked as reference, and then it can just assign here the value. What happens here is it behaves like a normal variable, right? A normal variable. Here in this case, the normal variable on top, I can assign a normal value to it, and here, and then it will overwrite this value on this memory address. All right. So the reference is behaving like a normal variable later after it is referenced, right? After the second step, it's behaving more or less like a normal variable because I can assign it. But careful, when you assign a value to it for a reference, they are sharing the same, let's make here, this telephone number has the same address, which means here the same value, and he is using this one. So if you assign from here anything, the other will get also only that what you assigned here. All right, so far we know it. I tried to explain this and make sense. So, and now back to our variable. What is he doing in the second step? So what is the second step? Right now, that was the first step. I tried to assign the pointer to an address, right? The pointer variable says, yes, give me an address. We have it, yes. But what we do next? Let's test. Let's write the same thing like here. What happens if I write pointer variable? All right. That's cool. And now I use this assignment operator, right? So similar to this, because you see, when we compare this both here, they have these arrows, they point to the address, and this one just used the variable name and assigned a new value it. This one, yes, can assign a value to it too, perhaps. Let's do it. We are doing it, and I want, let's say, the value 103, and this is not working. Why? Here, let's hover over this assignment operator, and it says there's something like a value of type int, okay, cannot be assigned to an entity of type int asterisk. This asterisk is very small, I hope you see it, which means this one, this pointer here, is this type int, which means a pointer, and we can't assign int to a pointer. This is not really working. At least it says so here. So this is not the way we work. And my goal was what? What was my goal? I want access to this address value here. And this is not working like this reference here. The reference could access it very easy. We as a pointer, no, we can't. So we find another way. Okay, let's try to find another way. And this another way actually is special to a pointer. And this is also a little bit special. And now what we do is, if you want, so let me go here back fast. If you want, the pointer says, if you want access this value here, which is not my pointer value actually, because the pointer value, important value, means what we assign here on the right side. This is my pointer value, is our address. But if you want access to the address value, so you see this is another step, not my pointer value, you want access of the address value, which stored here, which is this below step. If you want that, then use a asterisk in front of the variable, and then you can assign a value to this pointer variable, which means you are not assigning a value to this pointer variable here. It means you are assigning this value here to the address value. Let me explain this again. This sounds more complicated than it is. So let's repeat this fast again. I want to assign a value to my pointer variable. The first step is you must think pointer means I need an address. Okay, and you can assign address with this and ampersand and then variable name. Perfect. But we are not interested in this, not really in this address as a programmer, this memory address. We are more interested in the memory address value. So my pointer variable value is this address, but we are interested in this address value. So we need from this point here one step go on. And this way to go on is made with this symbol here, which is called dereferencing a pointer, which means actually this dereferencing means don't give me back the pointer variable value, give me back the value of the pointed address, which means you point to this address, Okay, and now give me not this address back as value, go one step further and give me the value of this address. At start, this is, yeah, for starters a little bit hard, but don't worry, we will repeat this again. Try to understand this. And if you understand this, then you know what I'm doing right now here. And what I'm doing now here is I am writing a value in this pointer variable address value, which means here's my address. This one value is here, but my pointer starts here. It's pointing to this one. Deferencing means don't give me back this address value. Give me back his value of the address. Yes. And now you can write in a value. So this is a little bit strange because you have really think one more step, because we in programming till now, for example, all what we did, for example, creating a normal variable. Let me set this in contrast here a little bit. When I create a normal variable, let's call this one as the string my name and assign it, for example, coder. And you can see here in this example what we already know. Here we have only one level. We have here the variable name, here is the value, and I'm interested in program most time in this value, and that was it. That goes for many things till now. And with pointer, this goes not. We have to think one step further, right? And this one step further is actually these two steps here. And that means, oops, sorry. That means we have to learn, when you learn pointers, that the pointer variable has two values actually. First, the pointer variable, that was wrong phrase. The pointer variable has not two values, but the pointer variable has one value, which is the address. And if you are interested to assign a value to this address, then you have go one step further, which means you have to use the difference operator, which is this asterisk, and then the this pointer pointer variable name, and then you are at this level here, and then you can assign a value, get a value, like all a normal variable. Important is that you learn these two steps. And let's print this out and see what we have so far, because I talked much. We will see something. Okay, say out. I want to see first the value of this one here, which is my pointer normal variable. So my pointer variable. Make first here a new line, and then I write here pointer variable. And here we expect, when you write it this way, here you see no asterisk in front, right? Like here, no asterisk in front. Here we expect the memory address, which we not really use at start as a starter. And if we are interested now of the value of this pointer address, which means you have all time to think we are interested in the pointed addresses value. All right, so you go first to the address and then you say I want the value of this address, and that means make a asterisk and pointer variable, and let's make here faster new line as well, so we see this both here. Sorry. And with that said, we will check out what we have here. So let's see if we expect something strange or see something strange. And first of all, we ignore on top, these are the other ones, but here on bottom, the two ones here, we are probably, wait, I should get rid of this output here, so we are not confused with this one. comment this one out. So we deactivate this code. We learned this as well, right? We comment this out, which means we deactivate the code. So now we see it a little bit clear. So the first one is the address, which we expected, because here the value is this address, which we don't use as a programmer really. But we are interested in the value of this address, which is then used with this difference operator. And here I assigned it the value 103 in it, and we have 103. So that's good. That sounds not too complicated, I hope, till now, because that was straightforward, I hope, because with my strange diagram. And of course, read this again in books and so on. But as a programmer, really, we need just to know this line and then what this difference operator means here. Difference operator means I want access now the memory address, pointed memory address value. And then I can change it like a normal address. I can use it later. For example, here I used it. I printed it just out. And yeah, but here is a problem which I want to point out. You see this asterisk here is now on the left side again. And I said, if it's on the left side, it's probably a declaration. And in this case, it's not a declaration. This is a second use case. And this one must be not even stay on the left side, like you can see here. It can stay even on the left side or on the right side. That's, yeah, we have to learn this one. So what you have to learn on pointer variables is, first of all, start with the declaration. That's all time the start point anyhow. And we have to go back to the declaration. I said when we declare a pointer, we can set it to default values, which is there are different kind of default versions, older ones, new ones. And the one which we are going to use is, for example, when I declare this one at start, you probably know this one when, for example, for normal variables, I use this one most time with 0. But for pointers, they use actually something newer, better. You can read this in books why they use a null ptr. So they use, this is special made for this pointer variables, because this null means I set it to null. The 0 and ptr means pointer. It's made special for this pointer variables. So all time when you make this, we will use this null pointer, but you will see in many programming codes as well, null and 0. It's also possible. Yeah. So, but we will use here this null pointer. So this is the start point. Not all time. Sometimes they start directly with a, like here, they want directly a variable's address, and with this one they get access to this variable's address value. And that's actually all what we have to learn at start. But there are million things which comes after pointers, which makes a little bit more complicated. But this is more or less really the basics. You have really learned here. If you understand this one here, these 3 lines, then you are really good, because this is something very fundamental, and it will be complicated a little bit later, of course, but if you understand till this point, that's absolute perfect. That's absolute super, because that is the last thing what I want made. Why we need why we make actually this strange way, this 2 calls. I mean, as a programmer, I said we are more normally interested in just creating a variable and enter value, and we are anyway interested of the variables valued here, and we are doing this all the time. Why we make this here so complicated with creating here a pointer? The pointer points then to a memory address, and then we have special say to this variable address div reference it and go from this memory address and get me this value or change its value. Why we make it so complicated? Why not just go like all the other variables here directly anyhow to this point here and use it? There are different reasons, and one reason is why it makes this so difficult is because there are pointer operations which you can use and you can't use in references. This is the last thing what I want to mention here as a basic, because when we watch this again, here we have a reference again, back to our reference, and at start I said when you create a reference, you have at start assign it to a already existing L value, which is just anything which has a fixed storage, and you can assign to the storage and get information. And with reference, this one is a must at start point. Later, you can use this one by using this reference variable name here. All right, but what's the difference here in pointers? That's not the case, and that's a very big important difference. It says ask here for variable address of any address. It asks here on the right side any address. For example, in this case it's a variable address which I made, but a pointer you can set it to a null pointer like here, and that is not possible to a reference. That's not possible, because here it says you must assign me a place or don't use me. The reference says if you can't assign me anything on the right side, don't use me. Null, it's not possible. And in pointers this is possible, but what is the meaning of that? It is just setting to null. It's similar like a default value, and that's not true here, because the difference is if you can something do like this, you can set actively the pointer, right? So you can change the pointer. So for what I mean with that is the pointer here at start point, I said, okay, I want that you point now to this memory address, right? Here, my telephone number got here, this memory address. And this one is asking for a memory address, but I can change later and assign here another memory address. And you can't do this with a reference. A reference is fixed. If you assign it one time, it will stay all time at this point, this memory address forever, because the definition of a reference is so that it will stick to this one. But, and that's the big difference between a reference and a pointer. The pointer says, no, you can assign me whatever memory address you want later too. So after you at start, you assign me this one, or let's say it this way, at start you assign nothing, you use the null pointer, which goes to a special made memory address special for pointers, which indicates to no address. And after that, you can assign me anything you want. Just give me a memory address, not a normal value memory address, but you can give me whatever you want, and later you can change me, which means here, let me show you this value here. This, I can use now this variable name, which is a pointer, and let's make this one, it's a little bit, not difficult, but you see we have here many steps now. Now, this one here is the variable name, and the variable name can be assigned a new memory address. For example, let's create, I have created here this string here, right? And this time it's not an int. And I can ask here for this memory address, but I should not do this. Why? Can you think about it? Why I should not ask for this memory address when we watch it? This pointer here has an int, which means you are trying to have a type of int. So storage is probably int. That means assigning here a memory address, you should find an int memory address. So let's create another thing. So we don't use this string. We try to find the right type. So let me create you one int, my favorite number, and I call it 7, for example. And now this my favorite number is a created variable. It creates a memory address, and I say, okay, pointer, go from my telephone number, you pointed to this at start here, now point to this my favorite number. Okay, and what we do there again, we use this ampersand. This says get me this variable name's memory address. Okay, I get you it, and my favorite number, and okay, now I see. Now we have get here the memory address. Now I'm pointing to another place when I make this in my diagram, which means I would create now, let's copy this one fast, which means this value will be created here on a new variable, and creating means the same thing like here on top. I think I'm not going to do all things here again, but let's say fast, here is this, again, this 4-byte new memory address here, whichever this is. Let's call this anything here. And something like that. This is the new memory address. And the name was my favorite number. Okay. My favorite here. Here's an X, here's an A missing favorite number. And yes, this was our name. This one is connected to this one, and we have the value, which will value 7. Here is our value connected to this address. So the pointer started here, and let's do this one here. Pointer variable. Now my second step is I'm going to assign to this a new memory address. And what does this new assignment means? This arrow here will be changed now, which means this is my first. Let's make here a 1. My second call. In my second call, I'm changing now this pointed address. Now, after I make this one, which means I erase this one here, and now I point it to this here. So, and that's why pointers are so powerful compared to all other things. You can change the addresses here. As a programmer, we say, okay, we are not using this memory address directly, but we are using still these values. And with one more step, okay, but you can see with these pointers here, I can change it to any memory address which I want. The question is still not really answered. Why is this beneficial? The reason for that is we don't want, like references, we don't want create, for example, there are many reasons actually, there are millions of reasons, but one reason is we don't want create again, again a variable. We want not copy a variable. So we can use, for example, a pointer. And a pointer is then using this memory address, this value, and can change it from, with very little performance loss from other places. This is one reason, and there comes later more important reason, but pointers definitely performance and storage is one reason, because that's why C++ is very powerful. You can create these kinds of stuff, and then yeah, you are really fast. You have a really fast. But later we will see we will need this for more, let's say, more important other reasons. But at the start, that's enough. So if you understand this one, I think I put too much in this video, but I hope you understand all this, because these are more or less the really basics here. So you see, actually, when we count now the numbers, you need only understand this line here, 1, this line here, 2, this line here, 3, and this line here, 4. So actually you have just understand 4 lines. If you understand them, and later we will train. So training is of course another thing. We have to train and use them in code and change it. But first of all, if you understand these 4 lines, then you know how to use the pointer, the basics, and all other things what comes later are more or less variations, exceptions, special cases, and many other things in combination with other keywords, combination with other things, and so on. So, and yeah, I think this video is very long. I should stop here first. And yeah, I think if you understand this so far, that's good. If you don't understand it on the other side, no problem. Pointers is one of these topics, which is for starters not so easy, because the one reason is you can see we are operating on one variable. This is one pointer variable, and we have here different things to consider. First of all, this, yeah, like I said, this declaration here. Then this point as this register, how this register thing works in behind the scene. Then that we want assign what is the value. For example, here this is the value of the pointer, but if we want to use the register value and to assign it and then to use it, and then this asterisk is also sometimes a little bit confusing for beginners, because this asterisk looks like a multiplication sign as well, and in different situations it is. When it's on the right side, for example, let me show you this one. When you write here this one here, let me write here my favorite number multiplied. This time it's not a pointer. This time what I do is multiplication. My telephone number here. So we have to train this asterisk sign, because here we have a pointer variable, which means this one, the first one, asking for an address. The second one is using the address and getting the value. It's a difference pointer. And this case, it's not a pointer. This is just multiplication. And we have to train this as beginners. And yeah, and of course you must understand all these basic concepts what I tried to understand. But we will dive later in here a little bit more. This video was long, and I hope you read this also in the documentation in official C++ books a little bit more deeper, and perhaps more visual than mine. My diagram is, I made it very easy. At least I tried to simplify it so much I can, that it's covering all the basics, super basics, not absolute top accurate, but easy to understand, I think. And If you have understood it, very good. If not, don't worry. Sleep 1 week or 2 weeks over it and train it, and you will understand it later, definitely, with training. Not just with understanding, we train and train and train, and that will come with training. So don't worry if you understand nothing. That's okay. All right, with that said, I stop here. And if you have any questions, like all time, or any complaints, write it in the comments. And see you in the next, and good luck. Bye.